Hey boys and girls, this is Mr. Bell, Mr. Bell's Math. Today we're going to be talking about writing equations to represent situations, and this is lesson 11.1 in your textbook. Our essential question, or what I want you to know by the end of the video, is how do you write equations and determine whether a number is a solution of an equation. Okay, so we already actually know how to write an expression, so we're just going to go from the expression to the equation part, and all we're really going to do is add a equal sign and a number solution. Okay, so what we have is an equation is a mathematical statement that two expressions are equal. Okay, so two expressions are equal. An expression could be anything now, so remember that. You could have x plus 3 equals 5. Okay, x plus 3 is an expression, 5 is an expression. Okay, it doesn't have to have a variable, doesn't have to have a symbol or an operation in it. Okay, to make it an operation, or I mean an equation. So an equation may or may not contain variables. For an equation has, wait a minute, hold on. For an equation that has a variable, a solution of the equation is a value for the variable that makes the equation true. Okay, so what this is saying is that if we have a variable in our equation, then the solution for the equation is whatever it takes to make that equation true, to make that value for the variable true. Okay, so here we have a couple examples. We got a numerical expression 5 plus 4. Okay, that's just an expression. Here we have the equation 5 plus 4 equals 9. Okay, the equation represents a relationship between two values. Here we have some words that will describe this expression: a number plus 4, and we have, it's 5. And then we have a number plus 4 is 9. So here now you have is coming into the equation, and is, generally speaking, is going to represent that equal sign. Okay, an equation relates two expressions using symbols. I was trying to do it without coughing. Oh well. So here, an algebraic expression, n plus 4. All right, n plus 4 equals 9. So the value that makes this statement true is whatever n equals, and we know that n equals 9. All right. So here we're going to determine whether the given value is a solution of the equation. So we have x plus 9 equals 15, and we're told that x equals 6. Okay, so we are going to say that x plus 9 equals 15. Then we're going to plug 6 in to the equation. Hopefully y'all saw that. Let me just change colors here. I plugged in this 6 right here for x. All right, that's the 6, that's the x. So now 6 plus 9 is 15. 15 equals 15. So that's a true statement when x equals 6. If x equals anything else, it may not be a true statement. All right, so let's look at the second one. We have y over 4 equals 32, and we have y equals 8. All right, so let's go ahead and write this. We got y over 4 equals 32, and then we have y equals 8. So I'm going to substitute 8 for y. So I have 8 over 4 equals 32. So I have 8 divided by 4. 8 divided by 4 is 2. So guess what? This does not equal. So this is not a true statement. Okay? Not when y is 8. Okay? It doesn't make a true statement. Okay, I hope you all see how that works. Okay, now this one, it says you can represent some real-world situations with an equation. Making a model first can help you organize the information. So in this particular situation, we have Mark scored 17 points for the home team in a basketball game. His teammates as a group scored P points, unknown amount of points. Write an equation to represent the situation. So we're going to put up a diagram for Mark's points, and we're going to add that to the team's points, and that's going to give us the total points. Okay, so we know, and we got right here, Mark is the home team. Okay, so the whole team scored 46 points, including Mark. So we know that Mark's points plus the teammates' points are going to equal the total points. So we take 17, we add P to it, and that gives us 46. And then we can find the value of that by just saying, well, what operation? Well, let me back up here. We could think to ourselves, what am I adding to 17 to get to 46? Well, one way we can figure that out, because this is an addition problem, we can use subtraction to help us find our answer. So we could say 46, take the total amount of points and subtract out Mark's points, and that would be, we got to borrow here, that'll be a 3. Wait a minute, what am I doing? This will be a 16, and that would be a 9, and then 1 from 3 is 2. So the rest of the team scored 29 points. All right. Here we have something that says write an equation to represent the situation. So Marilyn has a fish tank that contains 38 fish. All right, so we're going to have, I don't know if it's an addition problem yet, but right now we're doing pretty simple problems. I'm going to draw my boxes. It says there are 9 goldfish and F other fish. So if they contain 38 fish total, if that's the total amount of fish, that's what is going to be my is. All right, and then it says there are 9 goldfish and F other fish, then the total of those 2 fish are going to equal 38. So I'm going to add those 2 numbers together. Okay, and to find out how many fish are the other fish, we would have to subtract, because here we got an addition problem to get to 38, so we have to subtract 9 from 38 in order to find out how many fish there are, how many other fish. So 9 from 38 is what? 29. Okay, so that is our F. F equals 29. Okay, now here in this particular problem, I forgot to add the actual problem. So it says Sarah used a gift card to buy $47 worth of groceries. Now she has $18 left on her gift card. Write an equation to represent this situation. Use your equation to determine whether Sarah had $65 or $59 on the gift card before buying the groceries. Okay, so it says here that we need to, the first step is to write a word equation based on the situation. So we have the amount of the card, we subtract the amount that she spent, and that tells us the amount that she has left. So we rewrite the equation using a variable for the unknown quantity and the given values for what we do know. Okay, so we come up with a variable for what we don't know, and we just put what we do know in the equation. So it says let x be the amount on the card. So the amount on the card, which is the unknown, and then we spent $47 because it told us that in the problem, and we had $18 left. Okay, so we come down here, we substitute 65 and 59 for x to see which is true. Here we substituted 65. 65 minus 47, is that 18? Well, it actually is, because if we do 59, we get 12. Okay, so the amount on Sarah's gift card before she bought the groceries wasn't $6. All right, it was 65. It was 65. For some reason, I think I knocked that off here. There it is, 65. I knew that was there. All right, so that's that. So we're going to do the same thing here on Saturday morning. Owen earned $24, and by the end of the afternoon, he earned $62. Write an equation to represent the situation. Determine if he earned $38 or $31 on Saturday afternoon. So we have to set up our equation just like we did before. So I'm going to set up a box, another box, an equal sign, and this. Okay, so now I need to figure out what I do know. So Owen earned $24. Okay, so I know in some part during the day he earned $24. And by the end of the afternoon, he had a total of $62. So what we need to do is find out, and let's use E for how much he earned. And we need to figure out that $24 plus however much he earned is going to equal $62. So based on what we did in that last problem, we need to substitute 38 and 31 into the equation and see if they work. So 24 plus, let's start with 38, does it equal 62? And then we have 24 plus 31 equals 62. All right, let's start with this one on the left. So 24 plus 38, 8 and 4 is 12, carry the 1, and that would be 5, that would be 62. Well, it looks like that's our answer, okay? Because if we do it over here, we got 1 and 4 is 5, and then 2 and 3 is 5. So that's $55, so that doesn't work. So our answer sorry, is $62. All right, so that's a real quick description on how to set up an equation and solve and figure out what the value of the unknown is.